thank you for the introduction. Thank you for coming to this talk. So I'll be talking about optimizing page load speed on the front-end side. The idea of the talk is to kind of give a general overview of, or perhaps better said, a glimpse into the vast landscape of front-end page load optimization. As most of you know, keeping up with the latest in web development can be a bit challenging at times, especially on the front-end side. And as a consequence, the same applies for web performance and page load optimization. New insights, methods, approaches are being discovered on a regular basis. There's many tools, techniques, and strategies that you can use and play around with. In regards to fine-tuning optimization, every web page is kind of a special snowflake. How well you optimize for it depends on which approach you take, which techniques you choose, and how creative you can get with them. Also, by learning how to optimize for the web, you can get a better understanding of how the browsers work and how the web works. On the other hand, looking from the user's perspective, web performance and page load speed have a big impact on user experience. They play a key factor not only in retaining users, but also in improving conversion rates, which is especially important for online businesses. There are many real-world examples of this. All the big companies like Google, Amazon figured this out pretty early on. For instance, Amazon calculated that a 1 second slowdown in their page load could cost them about $1.6 billion per year in sales. Google calculated that a slowdown of about 400 milliseconds in their search results could cost them about 8 million searches per day. Mobify did a recent study where they showed for every 100-second speed up in their page load, they could get about $400,000 more in annual revenue. So web performance and page load optimization matter all around, and optimizations of just hundreds of milliseconds can make a big impact. But how fast is fast enough exactly? As we saw, the faster the better, but there are some guidelines you can follow, and these guidelines were basically established way back in the 60s when a research was done on human-computer interaction speeds. The guidelines still apply today, basically, and the research showed that about 100 milliseconds is the limit for having the user feel like the responses are instantaneous from the system. About 1 second is the limit for keeping the user's flow of thought uninterrupted. And about 10 seconds is the limit for keeping the user's attention focused. After that, he'll want to switch to other tasks. So basically, you want to aim at 1 second page loads. This might seem a bit far-fetched, but one key thing to keep in mind when trying to achieve these kinds of speeds is to focus on improving the user-perceived page load speed. Now, what does it mean to have a 1 second user-perceived page load speed or 1 second page load speed? Actually, it's not that simple. There's not one single metric that can help you measure page load speed. There's a number of metrics. And before, the main metrics were kind of the timing of the page download event, the number of HTTP requests, time to first byte, page weight, but none of them were really relevant for user experience. A couple of years ago, new metrics were introduced that help with this. Some of them are time to first paint, time to first contentful paint, time to first meaningful paint, and time to interactive. The first two metrics basically tell us at which time the user feels like something is happening in the browser. The third and fourth metrics are, in many regards, considered the most important for measuring user-perceived page load speed, but they're also the trickiest to exactly measure. Time to first meaningful paint measures the time at which the user feels like the main content of the page is loaded. Time to interactive measures the time at which the page has become responsive. So there's a number of these metrics, and as we said, every web page is kind of its own little special snowflake, and in some cases you might want to pay more attention to certain metrics than to others. You can even define your own metrics with the help of the user timing API. You can gather the standard metrics with the navigation timing API or the performance observer API. Once you gather these metrics, you can send them to a server or to an analytics platform for further analysis with the help of the Beacon API. One thing to keep in mind with these metrics is that they depend on the user's device and network speeds. So it's very important when doing performance tests to keep in mind what kind of devices and network speeds you can expect from your users. So there's a number of tools that can help you with measuring page load speed: Lighthouse, Web Page Test, Calibre, Pingdom. Not only do these tools give you the metrics, but they can also give you some useful information on how you can make improvements. And some of these tools can be incorporated into your continuous integration and continuous deployment pipeline. Now, before going any further, you might have noticed that I've been mentioning web performance and page load speed. Strictly speaking, page load speed is a part of web performance. And in this talk, we'll be focusing on techniques and strategies for improving page load speed on the front-end side. So we won't be talking about back-end optimizations like optimizing database queries or back-end architecture, nor will we be talking about optimizing rendering performance like CSS, speeding up CSS animation or JavaScript code execution. Instead, we'll be basically focusing on optimizing the delivery of your static assets. So JavaScript, CSS, images, and web fonts. So how can you optimize the delivery of your static assets? Well, kind of from a high-level, simplistic point of view, you can do three things. You can reduce the size of your static assets. The less data there is, the faster it's going to get transferred. You can shorten the distance for the delivery of your assets, self-explanatory, and you can also be smart about how you load your static assets. These are optimizations mainly aimed at improving specifically the user-perceived page load speed. So the first approach you can take is to reduce the size of your static assets. There's a number of methods that can help you with this. Well-established methods. One of them is minification. With minification, you can save up to 50% on size. There are many tools that can help you minify your text-based static assets. So definitely something you should do. Compression is another one. You can save up to 60% on size. Kind of the most popular, well-supported format is gzip. There are other newer formats like Brotli and Zafli. They offer better compression rates, but are not supported as well. Also, it's worth mentioning there's two types of compression. There's static and dynamic. With dynamic, the assets are compressed on every request, while with static, the assets are compressed ahead of time. And basically, it's a bit more optimal, but a bit trickier to set up. Then there's image optimization. Images make up to about 60% on average of page weight today. So you can make some big savings on optimizing your images. Most common, you should be looking to reduce the size of your static assets, of your images, to their display size. Oftentimes we see responsive websites load the same images for their mobile versions and their desktop versions. You should look into using responsive images to help with this. You should also be careful about choosing the format for your images. For instance, these two images look the same, but one is 200 kilobytes, the other is 50 kilobytes. The difference is that one is a JPEG and the other one is a PNG. So you should be careful about choosing the format of your images. You can also look into some newer formats like WebP and JPEG 2K. They offer better compression rates, but are not supported as well, so you'll have to provide a fallback for the browser in those cases. You can also look into optimizing images for the web. So the images don't have to be at 100% quality. They can be at about 60 to 70% quality. The human eye can't really tell the difference. You can also look to strip out unnecessary metadata from images. There's many tools that can help you with this. With optimizing images, you can even use third-party APIs to handle all of this for you. There's a talk tomorrow if you're interested more on image optimization, so check that out. A common pain point today is JavaScript and CSS library bloat. We tend to include a lot of libraries that are not needed, or in some cases, we can go for a more lightweight solution. So you should definitely revise your JavaScript and CSS library usage, especially with JavaScript, because JavaScript is byte for byte the most expensive resource. not only does it take time to download, it also has to get parsed, compiled, and executed. So you should be very careful to eliminate any unnecessary and unused JavaScript code. There's tools that can help you with this. If you're using a modern front-end build tool bundler like Webpack or Rollup, you can look into tree shaking. Tree shaking is a concept that comes from the mental model of your application and its dependencies as a tree, where the dependencies are basically the nodes in the tree, and with tree shaking, you're getting rid of the unused nodes and branches. So definitely something to check out. One thing to note is that it works best with ES6 modules, so if you're using Babel, you should be careful about not transpiling your ES6 modules into common.js modules. Another common source of load are third-party tracking scripts and ads. So this kind of became most evident recently with the emergence of GDPR. A lot of sites had to cut down on their third-party tracking scripts, and in doing so, they became much more performant. One example is the USA Today page, which went from 5.2 megabytes to 500 kilobytes in page weight. So yeah, there's a lot of junk out there. And another common source of load can be web fonts. You should be careful about not including any unnecessary web font weights or variations. You can even limit yourself to a certain subset of web fonts. So these are some of the things you can do to reduce the size of your static assets. Another approach you can take is to shorten the distance for the delivery of the assets. There's basically two ways you can go about it. You can use content delivery networks. CDNs are networks of servers that are strategically placed around the globe. And basically every server has a copy of your static assets. When a user wants to visit your site, he grabs the assets from the nearest server. There are many other benefits to using CDNs. Improve security, they can help you optimize your static assets, they can act as a load balancer, and they offload traffic from your main server. So definitely worth checking out. Another way to go about shortening the distance is to utilize HTTP caching. This is basically the maximum what you can do. So with HTTP caching, you can store the assets on the user's computer in the browser's cache. This is of course relevant only for repeat visits. A kind of common setup is to set the max age property in the cache control header to a long period of time, like 1 year, and add a fingerprint to the file name. When the asset changes, the fingerprint changes, and the new assets are basically automatically loaded. If you want to use more advanced caching, then you should look into the cache control header and the ETag header for cache validation. And also sometimes it's useful to cache dynamic HTML for a short period of time, like 3 minutes. This can help with dealing with sudden traffic spikes. So for instance, if you have a blog post that hits the front page of Reddit or something and gets 1,000 clicks in 1 minute, then it's useful if your HTML is cached on a CDN. That way the CDN can act as a load balancer. So these are some of the things you can do to shorten the distance for the delivery of your static assets. And the third way you can go about it is to be smart about how you load your static assets. So these are optimizations aimed at improving specifically the user-perceived page load speed. Usually this means focusing on loading the above-the-fold content first and targeting metrics like time to first paint, time to first meaningful paint, and time to interactive. So how can you improve these metrics? Well, first thing you should do is identify the absolute minimum of your resources that are needed for first meaningful paint and page interactiveness. There's tools that can help you with this, like critical CSS, or you can use code coverage and dev tools. Once you have these critical assets, you should look to separate them from the rest and load them as soon as possible while deferring the rest. There's a couple of ways you can go about this. One of them is to inline critical assets in the HTML. This way the assets are sent on the first HTML response. This is kind of the most optimal, but it's a bit tedious to maintain this solution. And also you can utilize caching of individual assets. It's all or nothing basically. So another way to go about it is to use preloading through the HTML link element. With preloading, you tell the browser to download the asset as fast as it can. So you can utilize caching of individual assets, And also, but it does introduce additional HTTP requests. And also, it's not as supported as well, but support is coming along. Another approach you can take is to utilize HTTP to server push. With server push, you can kind of preemptively push your critical resources on the same connection as your initial HTML response. This is basically as optimal as it can get, but it's a pretty aggressive way of pushing your critical assets. And also, there's some quirks with HTTP to server push that you should be aware of. There's a great article by Jake Archibald on this if you're interested more. So another technique you can use for smart loading is prefetch. You can utilize it through the HTML link element, for instance. With prefetching, basically you can tell the browser to fetch the asset when it has the time. So it's going to fetch it at a low priority, and it also can this can help you basically with assets that you know that will be requested by the user in future navigation. So it helps optimize navigating through your application. For prefetching to be effective, you kind of have to know where your user is going next. To help you make these decisions, you can utilize an analytics platform or even machine learning. There's a library that does this all for you called Guess.js. You can look into it. So another technique for smart loading is code splitting. With code splitting, if you're using a modern front-end stack and a build tool like a bundler like Webpack or Parcel, you can utilize code splitting to separate your critical assets from your non-critical assets and to defer the lazy load the non-critical assets with the help of, for instance, dynamic imports. There's libraries that can help you with this. If you're using React, you can use React Loadable that helps you utilize code splitting on component level. Another common pattern for software design pattern that's used for deferring the loading of elements until they come into the viewport is lazy loading. It's usually used for images. So before you kind of had to tap into the on-scroll event to do this, but today you can use the intersection observer API in most modern browsers. It's much more performant. And also it's kind of it's normal to use a low-quality image placeholder while your images are being loaded. There's even a tool called Squip that can generate low-quality SVGs that look like your images, which is kind of popular in today's sites. So these are some of the techniques you can use for smart loading. And in conclusion, basically, one thing to note is that web performance and page load optimization are often thought of as kind of a checklist that you go through and then move to done. But in reality, it's a continuous process, and you should look to constantly measure and monitor your performance. And also, you should look to set up a performance budget and use it when planning for new features or making changes to features. Otherwise, your one-off optimizations are gonna get lost in the long run. An often misconception that I've come across with is that page load optimization on front-end side is often boils down to minification and compression. Well, as we saw here, there's much more to it. And really, I just barely scratched the surface here. I didn't talk about many other techniques and strategies like server-side rendering, service workers, purple pattern, or web font loading strategies. So really, there's a vast amount of techniques and strategies that you can utilize. You should look to do so because it makes an impact on your product. It makes an impact on user quality and ultimately its success. So that's it. Thank you for listening.
Wonderful. We actually have a few minutes for one or two questions, if there are any. Don't be shy. I know you're all hungry and excited to get to lunch. Any questions? You can always chat with Krešimir at the reverse. Oh, question over here.
Hi, can you hear me?
Hi.
What is the strategy of defining a performance budget? What do you usually take into account when delivering the performance budget?
Yeah, well, yeah, there's many ways to go about it, but usually you even want to look at your competition and look at like if you have a product that's in a specific branch, then you want to look at your competition and see what are their loading speeds, and usually you want to be some percentage faster than them. So these are kind of the targets you want to aim, and usually in the beginning you should look at what kind of speeds you have and try and kind of figure out what's the best baseline for your product. So there's many strategies involved. But yeah, you want to keep in mind your competition. You can't set up kind of too far out goals, basically. Yeah. Okay. Welcome.
Any other questions? Huh?
Hi, great, in my opinion, a very important talk. What's your opinion about today's trend of preferring developer experience over user experience and basically just NPM installing the entire web and development like, okay, we're going to build a web page, so we need React, React Redux, React Router, a few NPM libraries, so we have like, what, 300 kilobytes of gzip JavaScript. Okay, now we start developing. Like, there's no turning back once you go down that road.
Yeah, I totally understand. That's a common pitfall. Usually performance is in hindsight for development teams. Developers focus on the code, but you know, you really should take performance into consideration, and that's why I said it's a continuous process. You should bake it into your development process. You should consider it when making, you know, when planning changes, you know, so you should bake it into your development process. You should make aware of your colleagues and your managers of what the benefits are, and you have to just make aware of your surroundings, how important it is and why it matters, the performance. So that's kind of my answer, I guess. Short.
Time for one more question. All right, well, let's have another hand for Krešimir.
Thank you.